Welcome to today's training. I'd like to turn it over to our Chief of Training and Products Manager, Dan Miller. He'll be presenting for us today alongside Per and Mikkel of FIREMIKS, and we'll introduce them to you as well.
Hello, everyone. Again, my name is Dan Miller. Thank you, Heather. Thank you all for joining us today from wherever you are located. Again, if you would please place in the meeting chat where you are from, who you're representing, what your role is. That helps us really dial in the course presentation to your needs. Also, we have with us today Mr. Per Erdahl, president of FIREMIKS. And FIREMIKS is located in Sweden, and they manufacture the FIREMIKS water-driven proportioners, and HCT, Hazard Control Technologies, is the sole U.S. distributor for FIREMIKS water-driven proportioners. So today what we're going to do is cover the basics of water-driven proportioning with FIREMIKS and talk a little bit about some of the pluses that can be gained by the use of FIREMIKS over things like bladder tanks and other systems that are available. So we'll go ahead and get moving on. At the end, we will have a session for question and answers. There's a separate button in Zoom for question and answer, so please use that Q&A button if it's available to you, which it probably is. If not, just use the chat. We'll check both for any questions you may have, but we'll have a question and answer session at the end. And we also have Michael Arendal with us, also with FIREMIKS, the manufacturer in Sweden. So if we get into really technical questions, they're here to answer those as well. So HCT and FIREMIKS started working together about 5 years ago, and that's when HCT became the sole U.S. distributor of FIREMIKS water-driven proportioners here in the U.S. HCT has 28 years of experience in fire protection here in the U.S., and together we have 46 years of experience, or excuse me, FIREMIKS has 46 years of experience. Together we have 74 years of experience in the fire protection industry. So as many of you know, or you probably wouldn't even be on this presentation, PFAS containing products are having to be moved out of most facilities, either at the behest of regulating agencies or insurance companies that may have to pay the costs associated with contamination. And then also they are a toxin, long-term cancer-causing risk. So we're trying to eliminate PFAS contamination and either switching to fluorine-free foams or at least away from fluorinated foam type concentrates. FIREMIKS is designed to integrate seamlessly into existing systems. You know, we can't eliminate the PFAS for you, so you have to work through that on your own from an engineering standpoint to eliminate any of that contamination. But when it comes to inserting a better proportioner into your system, a more reliable proportioner that doesn't require high maintenance or complicated maintenance, FIREMIKS is perfectly suited for that purpose. So the mounting consequences of PFAS include environmental pollution and fines, either from accidental spillage or when it's actually applied to a fire. It's not helping the situation other than putting out the fire, because adding to the contamination. So everyone's moving towards fluorine-free products. There's been many class action lawsuits against almost every foam manufacturer in the world. And a lot of that's due to the compromised community health and mounting evidence that PFAS has really caused a lot of worldwide contamination, damage, health issues, et cetera, et cetera. And it's PFASs are very pervasive. That's why they were intentionally added to products like AFFF, is because it really, really helps that little bubble resist the chemicals that it's floating on. And it keeps those chemicals from breaking down that bubble. PFAS is also included in things like rainwear and turnout gear and things like that to resist water transportation across the barrier. So it really is a very effective chemical, but it causes contamination because it gets into the tissues in your body, gets into the soil, gets into the groundwater, and then PFAS has been found all over the world, even where in places where it's never been used before. A PFAS contamination situation can really result in damaged reputation for the owners of the facility, managers of the facility, as well as fire protection contractors and engineers that are involved. So it really has to go at some point.
Hey Dan, sorry to
Yes.
interrupt. Some of our viewers are just having a little trouble hearing you. If you could maybe adjust your headset a bit.
Yeah, I'll give it a try. How's that? Is that
Great.
That's
better?
better.
Thank you.
Okay,
Better.
very good. What little fraction can make a big difference.
Mm.
Um, so, according to recent test results by the EPA, there are over 9,000 sites in the U.S. contaminated with PFAS, and those sites span across all 50 states and all territories. Um, and really, like I said, it's been found worldwide. Here's a little US map showing where there's some point sources of PFAS contamination. Many of these are sites where there was some manufacturing done, maybe some military stuff done, some training done, airports where fire training took place, places where previous fires have occurred, or this product was maybe discarded, sometimes appropriately. As we may have thought in the past, it was being discarded appropriately. I have 40 years in the fire service myself. We used to be encouraged to use all the foam we could during training, so we got good experience with it, and then we would scoop it up with our hands and pass it around and all kinds of stuff. So it was trusted, uh, but we know better now that with the PFAS uh, in legacy foam products, that really not good for you, not good for the environment, and very, very hard to clean up because it's so pervasive and can absorb into so many materials, leach into ground, water, and then travel. So, looking at some key factors into safely switching to fluorine-free products, we have to look at the hazards themselves. So, fluorine-free foams can mitigate two-dimensional Class A or Class B fire hazards or help mitigate those. Looking at the hazards, looking at the appropriate products that are available on the market now in the more synthetic foams and the ones that don't contain PFAS, you have to make sure you're using a good foam that's compatible with it. And along comes with that is differences in uh, um, drawing a blank here on my words, differences in the I'm really drawing a blank on my word. Uh, in the viscosity, excuse me. Couldn't think of that word all of a sudden. I apologize. In the viscosity of the various foams. So we have to make sure we're appropriately applying and using the right FIREMIKS proportioner, which we'll talk about here in a little bit. There are different fluorine-free foams. Some perform better, some perform worse, depending on the environment in which they're being used and the chemicals in which they're being used against. Um, their equipment, selecting the appropriate proportioning equipment is very important, and that's why we're here to help you with that today. And then application rates, just in general, from the studies that have been done, even in places where there was no wind, no rain, uh, and no mitigating factors, fluorine-free foams require a higher rate of application in general. We'll talk about that a little bit. So if we look at AFFF, pre-2001, AFFF post 2001, and fluorine-free foams, or F3s as they're called, and look at some of the different factors involved here, like PFAS content. You had around 5,000 to 11,000 parts per million of PFAS in legacy AFFF. And then after 2001, they tried to switch to something called C6 foam away from C8. It's just a different hydrocarbon chain. And that also contained PFAS, and they thought, well, this is going to be safer. Well, it turned out it wasn't very much safer and was just as pervasive. So they had to move away from that as well. But that had a uh, uh, lower level of PFAS in it, from 500 to 1,500 parts per million. And then the new fluorine-free foams that meet DoD specifications, Department of Defense specifications, contain less than 1/1000th of a part per million of fluorines, which is very easy to pick up even from the water that is used with that agent. So the lab viscosity on these uh, for AFFF pre-2001 and post-2001, 3 to 5 centipoids, and then with the F3s, it's 25 centipoids, 2,500. Real world viscosity, however, shows that the fluorine-free foams have a much higher viscosity, which makes them less pourable, a little more difficult to work with, and that's that they get up around 4,000 centipoids, very viscous. Um, the application rate for AFFFs pre and post 2001 was both at 0.10 gallons per minute per square foot on your typical hydrocarbons, but it's taking 150 to 300% more for the same results with the application of an F3 or a fluorine-free foam. And part of that's been its ability to hold down a high vapor pressure product. It really, really struggles with that. So why method consistency matters. So all foam concentrates, AFFF can maybe sometimes be a little bit of both, non-Newtonian or Newtonian, but the alcohol resistant AFFF and the fluorine-free foams are all non-Newtonian. It means their viscosity is not fixed. It changes depending on temperature, what spindle you shear with, um, how fast you shear them. So it comes down to pourability and how even it pours out, how easy it pours, etc. How easy it flows through plumbing, how easy it can be proportioned, and how evenly it can be proportioned. Because of those sensitivities, those viscosity values can't be compared in good faith unless they're measured under the same conditions. A lot of manufacturers, you'll see if you try to dig into the data, it really sometimes is obscure in their data how truly viscous their product is. So you really need to dig into that research and know that it's going to work for you. There are different method variables in um, in testing shear, spindle shape, spindle size, RPM, and temperature. A lot of them do it differently from one another, so it makes it hard to compare directly between the different products. So if we look at lab versus real world, you can see on the chart on the left how AFFF stays near water viscosity in both the lab and the field. But when we take fluorine-free foams or F3s out into the field, they have a much higher viscosity. And then if there's a little bit of a temperature difference, especially if the temperature is dropping, getting colder, that viscosity goes way, way up. So talk a little bit about proportioning systems here. Uh, most of us are familiar with bladder tank systems. So bladder tank systems have a lot of, I would say, somewhat intricate parts, and those have to be maintained, inspected, tested, and that installation, use, maintenance, and testing can really add to the total cost of ownership of a bladder tank. But they can be used for high viscosity fluorine-free foams, but only typically with some pretty significant design changes that can result in quite a few expenses. And then in most cases, what we've heard is that you cannot reuse a bladder tank because of the PFAS contamination in the previous bladder tank. It becomes really difficult to get that cleaned out. Um, so, but using a fluorine-free foam in a bladder tank requires larger concentrate lines because of that higher viscosity, modified proportioners, ratio controllers, things like that. With high friction losses and reduced venturi suction can limit the accurate proportioning range and capability across those ranges of different flows that you're trying to achieve from the lower end of your uh, system demand to the higher end. So it makes an expensive bladder tank even more expensive to maintain over time. And then when you do test it, a bladder tank, you're always going to have that waste material that is expensive to dispose of. And that adds to the total cost of ownership, just getting rid of that material. What we've noticed as someone who directly does supply some bladder tanks, and there's a rising cost in those bladder tanks due to the increased cost of steel, the bladders themselves, and the parts associated with them. They do have inconsistent proportioning with the higher viscosity materials, so that's a concern. There's a complex setup and maintenance, and it gets expensive just for that and the testing and the elimination of the waste material afterwards, the effluent. And then uh, uh, the limitation to me is one of the big things that we can get past a little bit easier with a FIREMIKS water-driven proportioner for several reasons as we look at these water-driven proportioners and their benefits. Play a little video here on how a FIREMIKS water-driven proportioner functions in a system. So as we look at the water-driven proportioner, you're going to see on here you have a bronze model here. There are ones available for freshwater, saltwater, high-pressure systems as well. So we have a wide range of them available for your specific needs, all the way up to 10-inch in diameter. So they will fit a wide variety of situations, and if it requires, we can go side by side and proportion dually to reach those higher volumes. So what the nice thing about a FIREMIKS is it's just a mechanical piece of equipment. So that water motor that's facing the screen there is driven by water. The speed and velocity of that water is determined by the system demand, how many sprinkler heads are open or how many deluge heads are open. The water motor spins proportionally to that. The RPM changes and drives either a piston pump or a small gear pump. And the product is then proportioned very, very accurately into the output stream. So there's no need for pressure balancing. There's no concern about elevation beyond the proportioner, which there would be with the orifice-based stuff. It's really very, very simple. It's strictly RPM based. It's volumetric because of that. It's driven by water flow alone. So even if there's a power outage, some kind of damage to the grid or something like that, if a fire breaks out, the solution is still going to flow. There are several FM approved models in the line as well, which we'll show you here in a minute. So these really, the water-driven proportioners help you protect facilities across a wide range of hazards and a wide range of situations with different hazard classes, from Class A to Class B, combustible dust situations, power plant situations, transformer protection, things like that. But your flammable liquids protection systems that are in place, we can match whatever the output needs are with either single diamond dosers or multiple diamond dosers side by side. To increase sustainability, a switch to your fluorine-free foam to avoid contributing to that growing PFAS epidemic associated with AFFF this is a great way to do that. It's very cost effective. One of the really nice things about that I see about a water-driven proportioner like this, and having no defined quantity by just the bladder tank size alone, is you can back it up with a concentrate tank of whatever size you deem necessary based on the duration of flow. But really, probably the least expensive part is having a bigger tank with a little bit more concentrate in it, 1.5 times, 2 times what you might need, and/or a reserve on site that you can then plug in and continue operations. It really makes that sustained attack very, very simple. And when it comes to testing, we have a zero waste testing process when you add a dosing return valve to the system, which we'll talk about in a minute. But the dosing return valve briefly just returns the concentrate back into the concentrate tank, so you're not wasting it onto the ground or into a bucket, never to be used again, and you don't have to dispose of it that way. So this is the range of FIREMIKS water-driven proportioners from your 180 liter per minute all the way up to 10,000 liters per minute. And you'll see your minimum and max flows over here in gallons per minute too. The model number is the max flow in liters per minute. As that converts to gallons per minute is included in this chart. If you want it the other way, depending on where you're located, we can easily get that to you. And then your inlet and outlet size are the same. So that also relates, of course, to your size of your risers that are currently existing or that you're designing into a new facility. So if you've got a 6-inch riser, for example, there are a few models available there for your different system demands. And then there are 3 currently approved, FM approved water-driven proportions, the 1800, the 2400, and the 4000. And there are more pending at this time. So those are coming along. So some frequently asked questions that we get, and if you have already asked these questions, no problem. But if you have questions that these FAQs don't answer, be sure to ask those as well. Number one, do we need a pressure tank? No. FIREMIKS with a FIREMIKS water-driven proportioner, it's it's draftable out of a tank. If you're using a high viscosity liquid, and we go with the gear pump model for a low viscosity liquid, that nearby atmospheric tank that sits above the inlet, then gravity flows into the FIREMIKS water-driven proportioner. But either way, it's just the concentrate is simply stored in an atmospheric tank. And again, it's very easy to size that tank for your needs as long as you have room in the building for it. Okay, would you recommend that we add a dosing return valve? Yes, because it lowers that total cost of ownership from testing, retesting, even uh, weekly and monthly when we would want you to maybe manually spin the FIREMIKS water-driven proportioner just to do a maintenance spin on it. You can dose it back into the tank, and you're not losing any product onto the ground or into the discharge or output side of the diamond, or excuse me, the water-driven proportioner into the riser. So you're maintaining your concentrate level. There's nothing to refill. It makes it very, very simple for you to maintain, either with, your frequent checks on site or having the fire protection contractor coming in and doing annual tests, for example. Um, Can you install a FIREMIKS pump into an existing fixed system? Absolutely. All we do is put a bypass in the riser, make sure we meet the minimum pipe length before and after the diamond doser so that you have good laminar flow through the diamond doser of water and not turbulence. And everything works very, very, it's a simple installation. Requires a little bit of room, maybe for the diamond dose, or excuse me, the FIREMIKS water proportioner and the uh, atmospheric tank, maybe 100 square feet for all of it put together, maybe a little bit more if you're going with a larger tank. Can we install them in parallel? Yes, they can be installed in parallel. That way, you get more or less twice the maximum volume out of your water-driven proportioner as you would with a single one. And there are, of course, advantages to that, and disadvantages as far as it refers to um, laminar flow, harmonic pipe flow, lack of vegetation, all those kind of good things as the product is flowing through it and the water is flowing through it. So it's time for questions. Let's look at what we have here. Heather, is there a separate Q&A button on this one or not?
Yes, on the bottom
Oh, I see it.
toolbar. Mhm.
I see it. It's over here to the right a little bit further than I was looking. It was on one of those little 3-dot things. What is the difference between this proportioner and fire dose? And is your product FM approved? So we covered the FM approved models that we have. There are more pending. I'm going to refer that to Per or Michael. What would you say the biggest differences between the FIREMIKS and the fire dose?
Michael, or
Yeah.
should I take it?
I would say one of the biggest differences is the design of the water motor. So we call it a multi-vane motor. So it consists of 4 or 5 overlapping vanes, which means that they have 8 or 10 contact points with the inner housing of the water motor. And the fire dose, they have 2 overlapping vanes, so they have 4 contact points. And our design, we believe, is more robust, and it spreads the load of the water flow onto more contact points, which gives a more robust solution, I think. That's one of the main differences.
Very good. Good explanation. And we do have charts that help you decide whether to go with the piston pump on the output or the gear pump based on viscosity of the concentrate that you're trying to move. So
Mm.
next question is, you refer to it as a pump, and what we refer to as the pump is the output side of it. So the water is driving a water motor, turns a shaft. That way it turns the concentrate pump on the other end of the shaft. So it's exactly matched to the water flow. NFPA 25 is for maintenance, inspection, and testing, and this does fall under that. So um, I don't see any reason why it would not be included in that. Anybody else have any input on that?
We agree. Yes. Yeah.
Yeah, as far as we know, there's no workaround for it. It still falls under 25. So
Mm.
I
any
think we
other
also
questions?
refer to NFPA 11 regarding the dosing rate and so on. The actual the 3.0 to 3.9, the NFPA and UL FM has this when we're checking the dosing rate, when we do our testing FAT, we follow the NFPA 11, FM, or EN 13565, all said 3.0 to 3.9. So, but all the others, NFPA, I'm not aware of everything. I would like to add one more advantage or the difference between FireDOS and FIREMIKS is that our multi-vane motor has less noise and less vibration because the internal design has developed since the original design from 95, which FireDOS is based on. So our design was made 2006, and one of the key factors for us was to lower the vibration, lower the noise, and have a more harmonic. And we reached that with the multi-vane motor. Okay, yes.
I can also add one. We have different production methods also. We use machined. The water motor is machined from bars, and so that means and FireDOS they use casted water motors. So that
Yeah, I
means
have
that
noticed that. So
we could for special applications we can make a customized sized water motor for even one unit. So it happens that a customer wants a customized size or a customized dosing rate also. For example, we had a customer that wanted a 2.75% dosing rate instead of 3%. And then we could adjust the size of the water motor in relation to the pump to deliver that solution. So we have a more flexible production method.
Yeah, correct.
So machined end plates and machined parts make that a lot easier.
Yeah, and less risk for corrosion. Yeah, when you cast, always small risk for corrosion in the casting, so you get leakage in the material. We have never had this kind of problem, as we are using bars and hard metal and machine it. So
right.
One advantage.
Here we have another question about need to consider head pressure, etc. You have standard pressure units and the high pressure. Can you discuss the various ranges in the standard units between the normal pressure and the high pressure for Michael?
We do have as a standard, we have the 16 bar for the piston pump, and for the gear pump, we say 12 bar, which is defined by the gear pump. But the actual piston pump takes much higher pressure, and we have made up to 30 bar and 40 bar. So it's just depending on changing the mechanical seal inside the water motor, so it can take it. The actual water motor is tested up to, I think, 68 bar by FM burst pressure, if I'm correct, around 60 at least.
60, yeah. So okay, so the working range for the pressure is between 2 bar up to 16 bar. So it's anywhere between there. And and the static pressure test we have done is 64 bar, 64 which is for the material.
Yeah. And each unit is tested double pressure. So for 16, I think we're doing up to 30 bar as our FAT test. No, 150%. Sorry, it's 26 bar. Sorry. Okay. But anyway, we can do higher pressure, and the only mainly up to 30 bar, mainly different is inside the water motor. The mechanical seal needs to be a little bit of higher quality, a higher pressure.
Okay, very good. So next question, is it suitable for F500? Yes, the piston pump version is. We actually, HCT manufactures F500, and we have a private label agreement with FIREMIKS for units sold with F500, and it's called the Diamond Doser. Same basic unit, same options available there. So just inquire with us. And that brings up a good point, is how do we acquire a FIREMIKS water-driven proportioner? You know, what's the supply chain look like? So HCT has manufacturers, sales representatives in all regions of North America, and we have distribution around pretty much the rest of the world as well. So if you inquire through our website and fill out an inquiry, we'll get you in touch with the right person that can help you specify and get a proposal on the right sized unit for your situation and the right piston or gear pump version. So we can definitely help you out there if you have special conditions, special needs. Again, we can work with FIREMIKS directly to get them to design a unit for your needs if there's some special pressures and things like that involved. Another question come up from Andre Barassa. Can it be used with salt water? Yeah, there's a bronze version available for saltwater use. So no problem there. And then, however, fluorine-free foams, I haven't seen one yet that's compatible with salt water. There may be some that are out there, but most of them are not saltwater compatible. So you may have to go with a different agent there, like F500 or one of the others that's available. Next question from Ahmed. Now we are using a foam proportioner around the pump. So what are the things that need to be considered while using this foam in an existing fire vehicle? Okay. I think what he's asking there, can this proportioner be used in a mobile apparatus? Yes. And that answer is yes. And they've done that quite a bit in Europe. Not so much here in the US yet, but it's definitely something we can do. There's mobile versions available that are outfitted with mounts and things like that are more compatible with mobile apparatus. So definitely doable.
Yeah, just one comment there could be that the around the pump system, typically you pollute the centrifugal pump with the foam concentrates. So one advantage with the FIREMIKS is that it's installed downstream the water, the centrifugal pump. So the centrifugal pump doesn't touch the concentrate. So that's one advantage there.
With and around the pump, you cannot work off a fire hydrant in many cases because the system pressure is too high on both sides. Exactly. So there's not a differential. With a water-driven proportioner, you can work off a hydrant or another water supply indefinitely. So real advantage there.
Yeah. No, the round pump is quite simple, but has a lot of disadvantages, really. One of them is the pollution and also the pressure dependency. And one advantage we see with the FIREMIKS is that it can be mobile, but it could be installed in the truck to be there normally. But if the truck gets stuck, then you can take out the FIREMIKS and use it mobile. So the flexibility with the FIREMIKS is several times higher than the round the pump system.
We call it the demountable model.
Yeah.
So you can have a quick coupling on the inlets.
A portable unit that's mounted in more or less in a compartment, connected. But if you need to, disconnect it, take it out.
Absolutely. No. So you can 2-in-1 in that case if you simplify it. Yeah.
Excellent. And we do have portable units available if you're strictly going to use them with hand lines, and portable units are available. So
absolutely. Furthermore, it can be installed on trailers. That is something I personally think like very much. You put it maybe on 500 or 1,000 liter container, or you put an IBC container on a trailer and I put a FIREMIKS.
Right.
And this trailer you can move around and put where you need it. In a industrial, you don't have to build fixed systems everywhere. You can have just piping system, and then you connect the trailer to where the fire is. So
right, connect it right into the FDC of the building.
yeah,
And
absolutely.
the nice thing is, with these, again, we're not using eductors, so you're not worried about
Exactly.
loss beyond
No.
the proportioner or height above. So with an eductor, either of those makes proportioning not possible. So with one of these, as long as water is flowing, so is your solution. So
Yeah, exactly. So it could be 500 meter, it could be 2,000 meter, it could be 30 meter. It doesn't affect the as long as the FIREMIKS rotate, it just doses. Keep
right.
on dosing.
So you can keep your entire operation in the cold zone or outside of a collapse zone, for example, if you have a tall building, and still proportion agent into that building. We had a question that did come up about the different units available. Are there going to be any FM units above 1,000 gallons per minute? I'll let Per answer that as well.
Let's say what we have done, we cannot promise too much because FM takes their own decision, but we have passed the test for the 6,000 and 8,000 during the summer, the actual practical test. So we are in that way, we know that we have the right capacity. Now it takes 1, 2, 3 months maybe before we get the formal FM approval signed and stamped. But we are sure we will get it. Absolutely. Last time I spoke with the inspector, he said November. I hope he keep it. We have one small unit, 450 also. And all these are for 3%. But our goal is to also add the 1% and so on. So it will be a continuous process to add more and more FM approved. So we hopefully have, if not all, but most of the standard lines will be FM approved. That is our goal. Yes.
All right. Next question from an anonymous attendee. Can you talk about pricing and installation issues? So pricing, we probably won't really discuss here much on this, other than we know right now the price on these is less than a bladder tank, pretty much across the board for all the systems we've priced out probably in the last year and a half. It's less than a bladder tank. So it's really a good value. Installation wise, we do offer consulting with we do business to business consulting with fire protection contractors and installers. And then we also come out and do the commissioning. So that's something that we price right into the supply. So, and then next question is, does this model support have support for centrifugal pump? So it not being at around the pump proportioner or anything like that, it's on the pressure side of a centrifugal pump. So you would be pushing water through it and then proportioning agent and solution onto your fire, wherever your situation is or sprinkler system is, whatever. So you're going to put your pump in line ahead of this unit.
Yeah, and it could be a hydrant. If you have 3-4 bar from hydrant, it still works. It starts at around 2 bar, then you don't have very much throw length, but it starts to rotate, so you don't have much for the system. But the actual FIREMIKS works from 2 bar and up. So if you have normally a hydrant out there around 4 or 5 bar, then you get decent throw length anyway, jet length for them also.
And we do at your all the different sizes, cut sheets available, so you can see, your minimum and maximum pressures and flows, so that you're engineering the right unit into your system. So
there was a question. I think there was a previous question regarding tank positioning. So we always specify that the concentrate tank, the lowest point on the concentrate tank should be in line with the foam inlet of the FIREMIKS. So that makes sure that you have gravity feed of the concentrate into the foam pump. And you don't have to really calculate the pressure head on the inlets. Just make sure that the concentrate is flowing, that you have a positive pressure on the inlet of the FIREMIKS.
Now, do you recommend that even on the Newtonian?
Yeah, just for extra security also, if you for any reason would have a air leakage or something.
Air leakage.
Because then
Good point.
So it's always much more secure to have a gravity feed, because then you would notice if there would be any leakage on the suction line.
So when we're working out proposals, go ahead.
That is absolutely, as Michael said, this is what we say mandatory for fixed installation, to make it 100% sure that it's always started with concentrate. If you are on a fire truck or if you use it on mobile, then you can overlook it and you can help it by flushing the pump a little bit to get the suction. So it's not mandatory if it's on a fire truck or if you use it mobile to have gravity feed, although it's beneficial. But if you're there on the site, then you can help the piston pump to get the suction just by flushing it a little bit in the flushing system. So, but for fixed system, absolutely gravity feed.
Stop sharing for a second so that I can show one of the cut sheets real quick, because I think that's going to help answer some questions here with friction loss and loss through the FIREMIKS as well here. Pull up the right.
I think I can in between. I saw a small question: is it suitable for foam sprinkler system? Absolutely, it works very well in a sprinkler system if you want to add foam, as long as you are within the min and max flow of the system.
All right. Do a little sharing again here. So if you can see my screen now, there we go.
Yeah, here we go.
So this is a cut sheet on a 6,000 at fixed 3%. So if you look at your technical data here, you've got your water flow rate maximum, which is 6,000 liters per minute, and 1,585 gallons per minute at 728 RPM. The minimum water flow rate at 8 bar is 600 liters per minute, or 159 gallons per minute. The minimum water flow rate at 4 bar is 500 liters per minute, 132 US gallons per minute. And then viscosity range for this particular unit is from I don't even know how to say that for sure, but from 1 to 1,800 over 3,600 centipoids. The dosing rate. Go
it's
ahead.
Regarding it's for the two different measures. One is for 60 RPM and the second one is for 30 RPM.
Oh, I see that now. Okay, that makes sense. I'm like, I don't know what we're trying to say there. Okay.
In practice today, it's a bit higher, but that is some data set. We have developed a bit, but that's for sure.
Very good.
Yep.
Dosing rate is fixed at 3% for this unit. Max inlet operating pressure is 16 bar or 232 PSI. Factory tested pressure, it shows you that there. Suction height, this is a piston pump version, so it has to be gravity fed with the gear pump. You can put it lower, but it's not recommended. Gravity fed is still highly recommended. Operating temperature from 1 to 55 degrees Celsius, or basically Fahrenheit. Storage temperature in the dry condition. Again, this is going to be relative to your agent you're trying to put through it as well.
Yeah.
Can't go lower than it's going to go, right? Your connections, this is a cut groove by default, but because it's cut groove, you can modify it to different pipe fittings as well, whatever you need on the plant now.
Flanges or whatever.
You can do flanges and so forth. Your connection to your pump is 2-inch or DN50. Concentrate delivery pipe hose diameter, 2.5, recommended, 3-inch for long piping, high viscosities. That seems, oh, I see, the connection, inlet connection to the foam side. Okay, so down here though, it's got your pressure loss table. So you've got basically your pressure loss goes up as your liters per minute of volume being processed through the water motor rises, your pressure loss is going to rise. So you can calculate that into your charts. Obviously, you're going to want to calculate for your highest flow, so that you know you're not losing too much pressure with this unit, or if you need to put in a fire pump or something like that, you can design off of this chart pretty easily. You've got some optional things to choose up top, some optional parts and things to include, optional features and items down here, recommended spare parts, and these are kind of nice if you want the ability to rebuild a pump on site in an emergency, or should there have been a failure, you can have the kit on site ready to rebuild that pump, and they're not too difficult to work with. They're fairly simple.
Yeah, good that you show that. One thing I would like to add is that regarding the min flow, the min flow is specified when we reach the 3% exactly. That means that it's still working, let's say, for 200 liters per minute, or 300 or 400, but the dose rate will go up maybe from 1.5 to 2, 2.5, 2.8, 2.9, and 3% is when we have guarantee. The 600 and the 500 is when we reach the 3% threshold. But it still works, and it still doses far below this min flow. So it doesn't stop working as a min flow. That's important to know also.
Yeah, very important. Good information.
Yes. So, and these are the standard unit, and we could add or adjust. We do like to supply standard units, of course, but if someone said, okay, for us the min flow is very important, or the pressure drop is very important, then we can adjust this, take a standard unit and adapt it towards customers' request very easily, because we machine each motor to
very good.
So we have a flexible way of producing.
Excellent. Good to know. Good to know.
Mm-hmm.
All right, let's see if we have any more questions. Just make sure we got them all.
I believe we do have one more.
I had to find the button now that I changed. How many of these pumps have been installed in the US and Europe?
Many. In US, not so many. Yeah, but we have delivered the Diamond Doser and branded quite a lot. You can give them the references you have on that one. In Europe, a couple of thousand around the world since we started. Yeah. So we have delivered to around 40 countries around the world.
Very good. Here in the US, I don't know if Mike's on or not, but I would say hundreds here in the US. So so they're out there. They've been out there for a long time. They're very dependable. Yeah. One thing we know, however, is that if you try to run accidentally get some shop rags in the line and try to run it through the Diamond Doser, it doesn't work very well. So don't leave shop rags in the line. So Okay.
So,
Mike Reiner just stepped in. He's president of HCT. He said upwards of 250 here in the US. So,
okay. And so that was a short question last there. If it can be used with different type of nozzles, etc. So, FIREMIKS, the purpose of FIREMIKS is to do the correct dosing. So you will have the 3%. If it's a 3%, you have 1% if it's 1. Then how this works with the concentrate and the nozzles is outside. Normally, it's no problem with any nozzle as long as it's working. But we do not approve towards specific nozzle or specific concentrate. The only way we test is the viscosity. We are tested against the viscosity range. Then it's up to the installer or you as a supplier to say, okay, this works very good with that nozzle or that pump and so on. But we are just focusing on the proportioning and do that correctly.
There could be a lot of, I think about this a lot because I love food. I think there could be a lot of applications for this in the food industry, like syrup manufacturing, Coca-Cola. Getting that mixture just right.
Yeah. No, what we say, our FIREMIKS can be used anywhere between a pump and a nozzle.
Right.
And how this system looks like, it doesn't matter as long as the water flow our system and with reasonable min and max flow and min and max pressure. Then you have the correct dosing. And then you're free to build the system.
It's basically three things to consider. It's the flow range that is between the min and max flow. The pressure range is between min and max pressure, and the viscosity range is between min and max viscosity. Those three. If you have those three set, then you should give the correct dosing rate. And then what happens after the FIREMIKS is up to the nozzles or the designer to. Yeah. It doesn't really affect the FIREMIKS.
No. Correct.
Excellent
summary.
All right.
Okay. Yes.
Well, if there are no more questions, we will go ahead and call it a day. I appreciate everyone participating today. We had some great questions. I appreciate Per and Michael joining us for some really expert insight on the manufacturing of the FIREMIKS water-driven proportioner line. Again, if you're curious as to one of these can go into a system you're designing or protect for a hazard that you currently have, what you have to do is get on our website, hct-world.com, and fill out an inquiry. We'll get in touch with you. We'll fill out a little worksheet on your pipe diameters, water flows, pressures, all that kind of stuff, and get a proposal going to you. So.
Yes. Thank you very much. Thank you, Dan, and everybody who's listened and came up with questions. We learned also a lot by getting a lot of questions. So we thank you for this.
Thank you for participating.
Yeah.
Thank you, everyone. Have a good day.